In this video, I'm going to show you how the Pythagorean theorem relates to trigonometry and the unit circle. We're going to start off by thinking about the unit circle. Here we've got the unit circle drawn with a triangle in it, and this triangle is constructed for the point xy on the unit circle. It just goes over x units, up y units. And we're going to put an angle, theta, in this triangle. Now, let's compute some trig values for this triangle, and you'll see that something cool happens. So first of all, let's compute sine of theta. Sine of theta, well, that's just the opposite side over the hypotenuse. So let's plug in these values. The opposite side of theta is opposite the angle, so y, and that's over the hypotenuse. Hypotenuse is just 1 because this is the unit circle, radius 1. So y over 1, so that's just y. So sine theta is just the y coordinate here. And let's go ahead and compute cos theta. You can probably guess what's going to happen, but let's work through the steps anyway. Cos theta is the adjacent side divided by the hypotenuse. And adjacent side here is the other side, not y, not 1, but x, the side next to theta that's not the hypotenuse. So I'll put x up top here, and the hypotenuse is still just 1, and that just comes out to x. So y is just sine theta, and x is just cos theta. So that means the point x comma y can really just be labeled by cos theta comma sine theta. So let's go ahead and incorporate this into our diagram up there. X is just cos theta and y is just sine theta. So if you thought this was cool, just wait another second. There's another thing we can do here. We can apply the Pythagorean theorem to this triangle to come up with what's known as the Pythagorean identity, which gives the Pythagorean theorem in trigonometric form and exposes a really awesome relationship between cosine and sine. So let's start out by just stating the Pythagorean theorem for this triangle. We've got x squared, the first side, plus y squared, the other leg, equals the hypotenuse squared, so just equals 1 squared. So we'll just simplify that. So x squared plus y squared equals 1. And now we can go ahead and plug in for x and y. X is just cos theta and y is just sine theta. So let's do that. We've got cos theta squared plus y is just sine theta, and then we're squaring that, and that's equal to 1. And we can write it a little bit cleaner. Cos squared theta plus sine squared theta equals 1. There we go. There's our formula, the Pythagorean theorem in trigonometric form. And this is a really, really, really important formula. It's like the most important formula in all of trig. It's very essential and very core to trigonometry and a lot of math in general. So we're going to box it really big. And yes, memorize this, understand it, pay special attention to it, because it's going to come up in the following examples and also just throughout math as you learn more and more. So let's go ahead and use this theorem to do some computations. Now let's apply what we've learned to some concrete problems. So first problem, what is the value of cos theta at the point in the first quadrant of the unit circle where x is a fourth? We've got that point labeled here. X is a fourth. We set up the triangle, and we want to find cos theta, where theta is that angle within the triangle. And remember, on the last slide, we saw that this point, 1/4 y, or just any point xy on the unit circle, is really just cos theta sine theta. So cos theta is really just 1/4. 1/4 is cos theta. They match up. The coordinates match up. So that answers our question right there. Cos theta equals 1/4. Pretty straightforward. And now, what about in the first quadrant where x is 0.9? So we could go ahead and draw this diagram again, but we're just going to come to the same conclusion. Cos theta is just the x value. So if x is 0.9, then cos theta is just the same, 0.9. And then what about in the second quadrant where x is -1/3? So we could draw that. Again, that'd be like somewhere over here. We'd construct the triangle diagram. But the main takeaway would be that our point xy is really just cos theta sine theta. So if x is -1/3, then cos theta is just -1/3. Here's a similar example, except this time we're looking for sine theta. What is the value of sine theta at the point in the first quadrant of the unit circle where x is 2/3? So again, we've got our unit circle set up. We've got our x coordinate is 2/3, so we've got our triangle, our point, our angle theta, and we want to find sine theta. So this example is a little bit more involved than the previous ones. The previous ones, we were asked for cos theta, and we just looked to the x coordinate, which we have. And that's still going to come into play in this example, but we're going to have to do a little bit more. So let's label our point as cos theta, comma, sine theta. And we notice that, of course, cos theta is just 2/3, because that's the x coordinate here. 2/3 and cos theta. Now, how can we find sine theta? Well, we can use the Pythagorean identity. That gives us an equation relating cos theta and sine theta, and we know cos theta, so we can just substitute in 2/3 into this Pythagorean identity and then solve for sine theta. So let's go ahead and do that. So let's substitute in 2/3. We've got 2/3 squared plus sine theta, or plus sine squared theta, is equal to 1. And we can go ahead and simplify. So this is 4/9, and then plus sine squared theta is equal to 1. And we can solve for sine squared theta, get sine squared theta is equal to 1 minus 4/9, and 1 minus 4/9, that's just 9/9 minus 4/9, which is just 5/9. And now we can find out what sine theta is by taking the square root. We'll cancel that square. And so the question here now is sine theta the positive or the negative root? Sine theta, does that equal the positive or negative root? And to answer that question, we have to think about the cast diagram. So let's label that. Cosine is positive here. All trig functions are positive in this quadrant. Only sine is positive here, and tangent is positive here. So our point here is in the quadrant with A. All trig functions are positive. So that means that sine is positive in the first quadrant where we're looking. So we want the positive root. So we'll go ahead and take the positive root. So that's just root 5, and then root 9 simplifies to 3. So we want positive 5 over 3. And there is our value of sine theta. In the future, we'll also learn how to use the Pythagorean identity to compute values of trig functions in other quadrants of the unit circle.